Okay, so let's look at part B here of, once again, the sample for response question having to do with tossing a number cube, a die, and recording the values for each toss and storing those values in a one-dimensional array, which is what we've done. So we've done that part. It's get cube tosses. And so suppose you toss a number cube and you get a 1, and then the next time you toss you get a 5 and a 5 and a 4, a 3, a 1, and all these numbers, and you're storing them in a one-dimensional array called the result, right? Now, so we've implemented part A of this problem in the first part to this video, or the part 1 of this 2-part video. And now let's look at part B here, which is the get longest run method. So you're supposed to write this method, get longest run, that takes as its parameter an array of integer values representing a series of numbered cube tosses. Okay, so as its one parameter right here, values, it is an array of integers. So I need to send it an array here of integers. Well, get cube tosses happens to return an array of integers. That is exactly what they're asking us to send as a parameter. It's basically an array that represents of integers whose elements represent the number you get when you toss a number cube, right? So basically, whatever get cube tosses returns, we're going to send that to the get longest run. Now the method get longest run returns the starting index in the array of a run of maximum size. Okay, a run is defined as a repeated occurrence of the same value in 2 or more consecutive positions in an array. Okay, let's talk about what this means. Well, let's first talk about what a run is. A run, if you look at the array here, a run is basically classified as the time when you get a repeating number, a consecutively repeating number. And so the first run that you have in this array is 5, 5, because you got 2 5s. They're next to each other. Consecutive means one after the next, or one after the other. And so in this case, the length of this run is 2. And then the next run happens right here, where you have 4 2s. 2, 2, 2, 2. So again, this is supposed to represent you tossing the number cube and you get a 2, and then you toss again, you get another 2, and then another 2, and then another 2, and then finally you get a 6. And so the length of this run is 4, because you have 4 2s. And then you get another run here, 3, 3, its length is 2, and finally you get another run right here of 4 5s, and the length of this run is 4. Now, what the method is supposed to return is the index location of where the run starts, or where the longest run starts. And so what they mean is, okay, well, here I have my run. It started at this index location at 1. And then this next run, where you have 2, 2, 2, 2, 2, this run started at index 6. And then this run, 3, 3, started at index 12. And then finally, the 4, 5 started at index 14. And you're supposed to look at the longest run. In this case, well, there's a tie. There's 4 2s and 4 5s. And return the index location of where the run starts. Now, for runs that are the same, so 2 runs contain the length of 4, one that starts at index 6 right here, and one that starts at index 14, the method may return either of those starting indexes, meaning they don't care which one. If there are no runs at all, meaning if you never get a number that repeats consecutively, then return a -1. Okay, there's a lot to be said here. First, we need to traverse the array. We need to look at every element at the array. However, we also need to compare this element at this location with the element at the next location. We want to check, hey, are these two equal? And if they are, well, maybe we want to increase this variable called length of run by 1. Oh, and then you move on. Are these two equal? And if they are, you want to increase that variable, right? Yeah, so you want to keep track of the length of a run right here. For example, this would be two repeating 5s, and then right here I'd have 4, and then 2, and then 4, because I repeated 4 5s. You also want to store where a run starts. So right here, when I compare this 5 with the next number over, which happens to be a 5, they're equal. I want to say, okay, I'm going to increase my run by 1, and I'm going to store the starting location for this run in a variable, and that would be a 1 right here, the index location. Or when you get to this 2 and you say, okay, is this 2 equal to the next value? It is. Well, I know that I'm starting a run. I don't know what its length is going to be, but I know I've started one, so I want to store the 6, which is where the run starts, and so on and so forth. And what you want to do is, as you're storing these values, you want to make sure that you always keep the starting location of the longest run thus far. And so meaning when I get to this 3 right here, 3 is equal to 3, so I know there's a run here, and I'm going to store the 12. However, when I go 3 is no longer equal to that next value. This 3 does not equal that 5, and so I'm going to say, okay, the length of this run was 2, and I should have stored this length of this run because it's 4. It's the maximum length thus far, and so I would not want to replace that 12 with that 6, for example. So we're gonna make a few variables here. We're going to traverse the array. We want to compare elements that are next to each other. You compare elements that are next to each other by using the I and I plus 1. So if I is 3, you'd compare this element to the element at I plus 1, which is 4, and you'd compare these two. Those 3 and 4s might be a little confusing here. Let me use a different value. If I is 6, you want to compare the element at that location, which is a 2, to the element at I plus 1, which would be 7, and those two would be compared and they're equal. So let's start by writing the loop here. First, values, once again, is an array of integers. I'm going to start first by writing the for loop. For int, I want I to start at 0, I know that. I want I to be less than the length of values, and there will have to be a slight modification here, we'll see later. And I want I to increment by 1. And I know I want to do the following. If values of I is equal to values of I plus 1. Now I guess I haven't yet figured out what exactly I want to happen, but I know I want to perform this comparison because this is values. If we're checking to see if values of 0, which is the first element, equals values of 0 plus 1, so values of 1, that's the next element to its right. Now let's think of, I'm just throwing this out there, let's say that there's 5 elements in values. 5 elements, I'm making this up. If there are 5 elements, then length of values is 5, right? And that means the biggest value of I is going to be 4, because 4 is still less than 5. And that's going to give us a problem here because we're going to check to see if values of 4 is equal to values of 5. However, when you have an array with 5 elements, the biggest index value is going to be a 4 because you start at counting at 0. 0, 1, 2, 3, 4. And so when you do values of 5 here, we're going to run into some issues. And I guess the best way to do this is to test it. So I'm going to come back to this in a minute. It's by no means done, but I want to test this get longest run. I'm going to copy it, and I'm going to come here into my main method. Remember, in the main method is where when I run my code, when I hit this little run button, it looks for the main method, and it's up here, and so it starts running the code in here. And I'm going to say I want to run get longest run. I need to send it an array of integers, and here's an array of integers. Answer is an array of integers, and answer is what I get. It equals what get tosses returns. And so I'm going to send it answer, and I'm going to run. I'm going to compile. I forgot the semicolon, of course. Compile, and I'm going to run, and I'm expecting an error. And here's the error. It says exception in thread main Java lang, so on and so forth. They actually do tell you the line of code where this is happening in line 39. So that's right here. And basically we're getting an index out of bounds exception. And let's scroll a little bit here. Index 20 out of bounds for length 20. Because when I ran this, I had 20 here for the number of tosses, right? That's the parameter to get cube tosses. Here's get cube tosses. I mean, that's the second argument that's stored here, num tosses. If I put 5 here to illustrate what I was describing earlier, I'll also put a print statement here so that it doesn't print after the last thing I printed. So just a print new line like that. And I'm going to run. And now let's see here. So still index out of bounds exception. Index 5 out of bounds for length 5. What that means is that values has a length of 5. There's 5 elements. But the biggest index that is going to be in values is going to be 4, because we always start indexing at 0. To better illustrate this, let me show you right here what I mean. Suppose that your array is this array. It starts 1, 5, 5, 4, 3. You see there's 5 elements. Forget about the 1 and everything that follows. So there's 5 elements right here. 1, 5, 5, 4, 3. So the length of this array would be 5. And the biggest index value is 4, right? Right there. But what's happening is that 4 is still less than 5. And we're saying values of 4 is it equal to values of 5. But there is no values of 5. And so what I have to do here, I cannot go all the way to 4. So 4 is less than the values of dot length. What I need to do is I need to go up to 3 at most, and so I'm going to take values dot length, I'm going to subtract 1, and so that means that this is 5 minus 1, so that's 4, and the last number that is still less than 4 is 3, and so that would be values of 3 is it equal to values of 4, which is the last index in an array with 5 elements. Basically, anytime that you do a +1, I +1 in a for loop that is traversing in an array, in this case the array is values, anytime that I include I +1, I need to take the values dot length and subtract 1 from that and have I less than that. So I know I'm comparing these two. Let's see, what do we want to do every time? Well, I know I'm going to make a few variables. I'm going to make a variable called, it's an integer variable, and I'm going to call it MaxLength. MaxLength. I'll just put len. Now MaxLength is the length of the longest run. In the example that we have here, that should be a 4 because the biggest run is 4, and it happens here and it also happens here. Now I also want a a variable current length, which I'm going to abbreviate. And that's the length of the current run. Current run. And then I want also to be able to make a variable, an integer variable that stores where a run starts. And so, and right here, for example, oh, come on, it logged me off. Yes, it did. Okay, here we go. I had been logged out. Okay, I also want to store the location where a run starts. In this case, this run started at index 1. This run started at index 6. And then this run of 3 started at index 12. And then this run started at index 14. And so I might have to make an additional variable, but I think this should do it. I'm going to call this run start. And I'm going to initialize it to 0. So this is location index value, or index location, it doesn't matter, index value of where longest run starts. Now, you know what, I'm going to do something here where I'm going to say that current length, the length of a run, is actually going to start at 1. And the reason I want to do that is because when I compare whether an element is equal to the next element, if they are, then I know I have two values that repeat. So like 2 is 2 equal to 2, and I'm referring to this comparison right here. Not 2, I guess. Is 5 equal to 5? Which will correspond to when I is 1. When I is 1, so we're looking here now, then we'd be checking is values of I of 1, which is 5, the value is 5, is it equal to values of 2, and that also happens to be a 5, so that's a true statement. So that is true. Then I want the length to increase by 1, and I want it to be 2 because there's 2 repeating 5s right now. And so I know that if that is true, I want to increase current len by 1. Plus plus, like that. So I know I want to do that every time an element is equal to the next element. And I want it to start at 1 here. Okay? And so I also want to do that when this is true, I want run start to then equal I. And this only should happen when I start a new run. Okay, so now that we have this, alrighty, now when Curlin is 1, that's supposed to be the first number in your run, and so in this case that would correspond to this 5, and then I check to see if that 5 equals that 5, and if it's true, I increase current length to 2. And then right here, I would check to these two, and they're not the same, and which means I would set current length back to 1. And then I would come down here, and I would say, okay, current length is 1, and then it's equal to that. These two numbers are equal, so I increase current length to 2. And then these two are equal, so I increase current length to 3. And then this number is equal to that one, so I increase current length to 4. And what's true is that right here, when I had current length 1 and I increased it to 2 because these two are equal, I want to store that number, the index location, which happens to be I. I is 6, I plus 1 would be 7. And I would be comparing results or values of 6, is it equal to values of 7? and the answer is true. And right here, I'm going to say that if current length is equal to 2, that means I'm at the second value here. I'm going to say that the start of my run is going to equal I, where I, in this case, would be values of 6. Is it equal to values of 7? Is 2 equal to 2? The answer is yes. Increment current length by 1. It was 1, so now it's 2, and that means this is true, and I want run start to equal 6. Okay. I also want to perform another check here. Oh, actually, I'm going to say that if they're not equal, if the two consecutive values are not equal, so I'm going to put an else. What I want to do a few things here. I want to first check to see if current length, whatever that ended up being, right here. So let's say it was 4. You're on that run. Their values of 6 equals values of 7. Values of 7 equals values of 8. You're on this run right here with the 2's, right? Values of 8 equals values of 9. And you're going to get 4. Current length is going to be 4. And then you're going to check values of 9. Is it equal to values of 10? And the answer is no. And so I want to do a few things. First, I want to say that if this length, the length of this run, is greater than my max length, then I want max length to equal the length of this run. So I'm going to say here, if current length is greater than max length, which remembers that it starts at 0, right? Then I want max length to be equal to that current length. And so let me kind of give you an idea here of what that does. Right here in the 5's, the current length right here is going to be 2, and my max length is 0. And so my current length is greater than my max length. That satisfies this condition. 2 is greater than 0, and it's 0 because that's why I initialized it to. And so I want max length to equal 2. And then I'm going to get right here to this value where my current length is 4, because I've been adding to current length 1 at a time. And so 4. Is my current length greater than my max length? Well, my max length was 2 after this run, and so 4 is greater than 2. And so I want my max length to equal my current length, which happens to be 4. And so that's what this is going to take care of. I also want to, if the two consecutive values are not equal, I want to restart current length to 1. And there's one more thing that I want to do, and that's I want to store the place where a run starts. And I know I initialized it here. And so I'm thinking here. However, when I start a new run, it's going to get reinitialized, and I'm going to forget what the previous one started. So I am going to make two variables. I'm going to make here a current start and I'm going to initialize that to 0. And instead of this being a run start, I'm going to call it max start. So I'm doing the same thing that I did over here with max length and current length. And so max start is the index value of where the longest run starts, and current start is the index value of where the current run starts. And so right here, I'm going to make this current start instead. And I'm going to say that as I'm looping, If they're equal, that's good. Current start is here. And if this is true, the length of my current run is greater than the max length. I want max length to equal that, and I want max start, which means that I need a set of curly braces because I've added another line of code here. Is going to equal current start. Not I, but current start. And finally, what we want to return is this, max start, which is something to be said here, that if max start, or I guess I should say, if max length is equal to 0, that means that max length is the length of the longest run. If it stays at 0, that means that you never found a run bigger than 0. And if you never find a run bigger than 0, however, this starts at 1, right? So 1 is greater than max length. That means max length is going to be 1. Actually, if max length is equal to 1, which means that the length of a run, the current length of a run, always never exceeded 1. Never, ever. Because right here, 1 is greater than 0. And so max length is going to equal 1 for sure. But 1 is not, technically 1 is not a run, right? You have to get to at least 2. And so if max length is equal to 1, then we're going to return -1. Else, we will return max start. Let me compile just to verify that I'm not running into any errors. Let me comment. Here's some code here. So right here, compare current element to next element. Specifically, check for equality, see if they're equal. If they are equal, all right, so just go right here. Actually, well, right there is good. If they are equal, increment length of run by 1, and then if length of run is 2, store index value of where run started, which means like right here, as an example, where I have here values of 6 right here is 2, and values of 7 is 2, and they're equal. I increase current length by 1, and if current length is 2, because it starts at 1, current length is 2, I want to store I, which is the index location of where the run starts, 6. So if the length of the run is 2, store the index value of where run started, and that's what I do here. Current start is 6. And we're going to keep increasing. Well, this is true because we're checking progressively along the array. We're going to keep doing this, keep doing this, keep doing this. We're incrementing current length and current length until we get to a point where they're not equal. When they're not equal, we want to do a few things. We want to first compare length of current run to max length of, or max run length. Meaning, if the length of my current run is greater than the maximum length, which initially it will be because it's 0 and the current length is at minimum 1, then I want max length to equal the length of the current run. And so right here I'm going to set max length of a run to length of current run. We also want to do the following. We want to set the max start, which is a set index value of longest run to the length of the start index value of current run. And this talks about starting index value, starting index location. So set the index value of the longest run to the index value of the current run, which is given by this, right? Now, if this is not true, then you're not going to set this. Finally, we want to reinitialize the length of a run back to 1. Because every time that we don't have two consecutive values being equal, we want to make sure current length stays at 1 and stays at 1 and stays at 1. And then last but not least, outside of the for loop, we want to check check length of run to be more than 1, and this is maximum length, or length of maximum run, I guess. And if it's not more than 1, then that means we never found a run. If it is more than 1, then we're going to send the location of where that longest run starts. Starting location, right? Okay. This is actually pretty involved. There's a lot of checks, but let's test it. I want to print here. So print what system.out.println. Print what get longest run returns when I send it the array answer. And I'll write here starting as a string, starting run location, starting longest run location with a colon and like that. And I'm going to compile, and let's test this and hope, cross our fingers. Okay, right here there is no run. Actually, there is one right here, 6, and I sent a -1, so clearly something's wrong. Let me give this a pause for a minute so I don't waste your time. Okay, there's a few things here that are not quite working as I was expecting. First, if you notice, I ran here this number of tosses 5, and I have a run right here, and I was expecting that the starting location for this run would be 0, 1, 2, 3. I was expecting a 3 and I got -1. And you can see if I scroll up here, you'll see that it's worked on some. So right here, for example, 3, 3, 5, 5, 1, it returned to 0 because that's where the run starts. I also printed this got_you command to troubleshoot this. I also, if I scroll up a little bit further, here's another run where you have 1, 1 and starts at location 0, 1, 2, 3, 4. So at 1 and it returns that. So that's working correctly. What I need to do here is I want to say that if MaxLength is greater than, or I guess I should say greater than or equal to 1, I want to print max start. So I'm going to cut that from there and I'm going to paste it here. and I'm gonna then else return -1. So basically, if the length of my longest run, the length of my longest run is more than or equal to 1, return max start. Let me put it like that, greater than. And then the other reason why in this right here at the very end, where I have 2, a run right here at the very end, the reason why it's returning a -1 is because this is, I'm comparing the last 2 values. So values of 3 is it equal to values of 4, and I increase current length by 1, but I then do not come into this else condition. I don't. And I never set max length to 2, because remember, current length was increased to 2, and I also never set max start to current start. And so I'm going to take this right here and I'm going to cut it from here, and instead I'm going to put it in here. And let's then compile and run. Okay, so this works. Here's a run, and it starts at 0, 1, 2, right? Okay, let's run it again. There's no run here, so -1, that works. There's a run, 2 runs here at 0, and then at 2 and 3. Here's a run that starts at 1. Again, we start counting at 0 index values. Here's a run that is 3 numbers in length, and it starts at 0, 1, 2, so that's working good. And I can already see that this is going to work because this is the run goes all the way to the end. But let's run it one more time. No run here, no run here, run here that starts at index value 0, and then a run here that starts, well, 2, so that kind of messed me up. 2 runs. I'm looking for a run with 2 consecutive numbers that repeat at the very end. Oh, this is close right here too. And here we go. There we go. Here's a run that starts at index value 3. 0, 1, 2, 3. So finally it's working. Now let me increase the number of tosses here to like 20, and then see if that gives us more runs and some that are longer in value. Right here, for example, the longest run that you have is of 2 numbers, so 2, 2, and 2, and we kept the one that starts at the very beginning. It doesn't matter which one. How do we account for that? We could here, right, instead of current length is greater than or equal to max length, we could put in equals, greater than or equal to. And in this scenario, I suspect it would have given me this one at the end. But we don't care much for that. Let me run again. Again, the longest run is 2. Here we go. The longest run here is at location index value 10. And so if I look here, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 right here. Also 2 units in length. I'm looking for one that is, oh, here we go. Here's one with the longest run here. This is perfect. We have a run here of 3 elements, and it starts at 0, 1, 2, 3, 4. And then we have another run of 2 elements, and it starts at, well, whatever that value is. But then you get to this one, which is a run of 4 elements. And if I bet you money that if I start counting from 0 and I get here, it's going to be the number 13. And so might as well do it. There's 3, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And this is the longest. Whoa, did I just skip that? Let me do it one more time. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, we're good. So right there. This was actually a method that was a little more involved than I initially thought. I didn't code this beforehand, so I was coding this as I went. And if anything, I hope that doing so helps you just see how this kind of pans out. That said, if you have questions, please reach out to me. But this is a good example of kind of like the difficulty that goes into some of these problems.